right, so good afternoon or good morning, depending on where you're joining us from, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. If you're joining us for the first time, and I know we got a whole bunch of folks in BC doing just that today, we are all about bringing conservation, adventure, and science into classrooms around the world through over 50 monthly live free broadcasts. So if you check out our site on the bottom of the page, you'll see all those sessions. You can register for our newsletter, check out our YouTube channel where all our broadcasts, 2,000 sessions from 5 years can be located. Lots of great opportunities to have a lot of fun and learn a lot too. Now, this week is particularly special for us as an organization because we are joining forces with the Canadian Association of Science Centers for the Week of Wonder. This is Science Literacy Week, so this is Canada's largest science festival filled with virtual and live programs coast to coast to coast across the country. And to celebrate, we're partnering in for 20 live, free, amazing events with all these amazing science centers. Ontario Science Centre kicked us off on Monday. We're wrapping up with the museum on Friday, but today we are joined live at Science World, one of my favorite places I've ever visited in the country, Vancouver's go-to incredible place to learn about the world and cosmos around you. And so without further ado, we are going to dive in today on a presentation about Earth, wind, and science. We're going to learn about wild and wacky weather. We're going to do some amazing demonstrations. We are going to learn a lot and have a lot of fun. So without further ado, thank you so much for joining us, Science World team, and take us away. Hey, guys.
Thank you so much for that wonderful introduction there, Jesse. Hi, everybody from far and wide. My name is Josh, and I'm coming to you here from Science World here in beautiful Vancouver, British Columbia. I would like to first start off by acknowledging that we, as a Science World organization, are located in the traditional unceded territories of the Musqueam, Squamish, and the Tsleil-Waututh peoples, specifically the traditional village site of Sanok. I know we're all coming from various places, not just in British Columbia, but all across the country. And I understand we have some people coming from outside of Canada as well. Hello to all of you. I'd like to invite you, when you have that time, to take a little time to explore and learn about the history of the lands on which you work, live, and play. Learning a little bit more about our world makes us more informed citizens, and informed citizens is what we want to strive to be each and every day. In any case, today, as Jesse mentioned and kind of gave a big clue, our presentation is called Earth, Wind, and Science. And today we are going to be exploring weather. But before we do that, I just wanted to let you know that I'm not by myself as inside the studio that I am presenting in. I've got a whole bunch of colleagues helping me out over here with tech, making sure I sound okay, making sure I look okay, and making sure I've got everything that we need in order to get this presentation running smoothly. I've got Kate over there in the corner in my eye there. You can't quite see her on camera, but she's definitely doing her thing, making sure that I'm looking okay. Things are looking good over there, Kate?
She can't hear you, but
can't hear you, but I think
she was very focused on making you look good. Yeah.
Yeah, you hear a voice right over there. That's Stefano, who's busy just over there, setting up there. You better hurry,
Hi, everyone.
And we've got Brian over here to my right, who's operating our tech and making sure you can all hear me and you can all see me. I'm hoping that that's the case. I can't quite see you there, but I think if I were to ask you if you can see me, I'm hoping that the answer that I'm getting is yes.
We promise, yes. 1,000 times yes.
Awesome. Thanks, Jesse. And that also explains why we have our masks on. We're making sure that we're keeping ourselves safe while we're having a bunch of fun here with you all. Now, I want to engage with you a little bit here. I would like for you to share with us in the chat or maybe have a discussion with each other about some things that you would like to see in terms of the weather. So what is your favorite weather? What sort of weather would you like explained in our presentation today? We'd love for you to share with us on the chat or through any other method that is available.
All the methods. If you don't want to use the chat, you just want to yell really loud and hope they hear you in Vancouver, you're welcome to try that as well. I think the chat will be your best bet. We've got our one live class joining us at Cambridge Elementary and tons of folks joining us in Guelph, Stony Plain, Alberta, Squamish, Vancouver, Coquitlam, Cordes, all these amazing places around Canada. So if you guys want to let us know in the chat, what do you want to hear about with weather today? Okay, we've got snow, we've got hail. Those are our first weathers. More, keep them coming, guys. Snowy sunshine for Amy Sterling. Welcome in. Great. With a cool breeze. Sunshine with a cool breeze.
We don't need that.
The Sterling's class has got the right idea. That's what we all want, I think. Great answers, guys. Anyone else? Dun, dun, dun. Snow, a lot of snow. We got a lot of snow events. You guys just like longing for winter, I guess. I don't know.
That's an interesting thing for us here.
We've got hurricanes. We've got all sorts of stuff. There's like at least 10 classes in the chat. This is awesome. So snow is by far our biggest answer, but I don't know, sunny with a cool breeze sounds like a lot of fun. Up to you guys. Take us away.
Well, wonderful. Thank you for all that wonderful engagement you've given us. We've got plenty of material that we can do a really fun show with, and I'm really excited. But before we get into talking about and exploring those different weather patterns that you've given to us, we have to kind of really get down to the basics of it. We need to understand what's weather, right? So weather is the things that are going on around us. And we need 3 ingredients in order for us to have weather. We need, first of all, a heat source. The second thing is we need water, and we need air, or in more specific terms, an atmosphere. I want to draw a little bit of your attention to the atmosphere here. The atmosphere is made up of all of these different kinds of gases. As a matter of fact, the majority of our atmosphere is made up of nitrogen, 80%, approximately 80%, followed by oxygen, about 20%. And then the rest is about 1 to 3% of it's all these other different types of gases. We have carbon dioxide, that one you've probably heard of a lot, water vapor, and so on. A good mnemonic that I like to think about is to take your hands. So if you take your hands and you bring down 4 of your fingers, that would be about the nitrogen. So your 4 fingers here are nitrogen. Your thumb would represent the oxygen. And then, provided you haven't cleaned your nails already, all of the gunk underneath your nails represents all of the other gases in the atmosphere. So hopefully that's a good mnemonic or a good reminder to help you figure out what's in our atmosphere. So we need all 3 of those in order to create the weather. Now, today we're going to be doing some fun demonstrations involving the weather. Now, we obviously can't create weather indoors, because 1, we'd probably put ourselves in a very compromising position, and we wouldn't want to do that. And 2, because we're dealing with water, like I mentioned, water is one of the ingredients. We're going to get really wet. So what we're going to be doing today is we're going to be demonstrating the weather using things we call models. Now, models aren't perfect. They don't perfectly mimic the weather, but they have some things in common with the weather that we are going to be exploring today. And those similarities will help us understand the weather a little bit more. Now, I heard I think I heard a class say that one of their favorite weather patterns was a sunny day. Is that correct? Did I hear that? I think I did. You
got that right. We've had a few more sun lovers since we left our original question period too, so you're all set.
Yeah, you're the kind of people I like to hang with. I love the sun too. Well, let's talk about the sun. Let's get into the sun. The sun is the motor of the weather. It controls what sort of weather we're going to be having today. And I'm going to, like I said, model the sun with what I'm going to be doing today. Now, that we like to describe the sun as a big ball of fire, I think you probably agree. So I am going to simulate some fire today. But in order for me to do that, I'm going to have to make sure that I'm nice and safe. Because if I'm not nice and safe, then again, we're going to be in a little bit of trouble. Oh, Stefano's here behind me demonstrating that we've got a lovely, thank you for prize modeling this fire extinguisher for me, Stefano. That is our fire extinguisher, and in case anything goes wrong, we want to make sure that we're nice and safe. I've got my goggles on my face, making sure that my eyes and especially my eyebrows are not going to be singed. And I've got a fire safety glove over here in my hand, along with some tongs that I'm going to put a piece of paper in. And I am going to burn this. All right. Are you ready there, folks? I'm hoping you are all saying loudly and enthusiastically, yes. And on the count of 3, 1, 2, 3. Oh, wonderful. Did you see that? Did any of you see that? I must admit, it was a little bit fast, so I think we're going to have to do that again. All right. Let's do that again.
Hey, Josh.
Yes.
That burned faster. Is that normal paper?
Well, yeah, this is actually a special kind of paper, I should mention. I'll take my goggles off so I can see you all here. It is a special type of paper that we call nitrocellulose, and it's coated with a special material that allows it to burn pretty fast and also burn really quickly. You might notice that when you burn something like regular paper, it kind of deposits soot and some sort of like, debris or kind of residue. This one was completely quick. So we're going to do that again. Let's take a look. All right. Pay attention there, everybody, because if you don't, unfortunately, I have no more flash paper here. So, yeah. All right. Here we go. 3, 2, oh. Did you catch that? Did anybody of you catch that? I really apologize. I realized that I probably should have counted that a little bit better. Do we have anything perhaps that might... it was a little bit too fast there, Brian. Do we have anything maybe that we could demonstrate that's a little bit slower? Well, we do. And oh, no. Actually, now that you mention it there, Brian, we do. We actually have a little video in which we slowed down what was going on. Now, what I had here was nitrocellulose, or as we know as flash paper, but we have another thing that we're going to burn called lycopodium powder, and it's a very seasonal video, and I think it's time for us to show it to you. There we are. And on the count of 1, 2, 3, you can see it explode. Wonderful. Now, what was being demonstrated? Hello there, everybody. What was being demonstrated there was an example of a combustion reaction, which isn't the same as the sun. The sun is more of a nuclear reaction, but they do share things in similarities with us, which is light and heat. So light and heat is what we can get from our two reactions that we saw over here, our two fires, and the sun does that exactly the same way. So that was your demonstration for sunny weather, our driving force of the weather, the wonderful sun, which I believe is out in the air, shining brightly. I can't quite see the sun from where I am in our lovely studio, but I will get a chance to see if the sun's out a little bit later on. Let's get exploring into our different types of weather here. Jesse, were there more classes out there who wanted to share, or was there more interaction with the chat?
We had tons. I mean, a lot of rain, obviously. I think rain and snow, some sort of precipitation is our next best bet. We got some more down the chat too, but I think we have lots of time for demos. So let's start with rain or snow. I think those are ones that really jump out, and there's a lot of, and we'll go from there.
Yeah, well, you know what? Rain. I have a feeling that rain might have been mentioned from some of our British Columbia classes, especially those in the Lower Mainland, if you know what I'm saying. If you know, they're Lower Mainland classes. Now that we mentioned a little bit about rain and snow, I think the best thing to talk about is water. So let's get into, actually, you know what? In order for us to understand water and its effect on the weather here, I think I might need a class to come and help us out here. Now, there's something that we call the water cycle, and there are 3 key words that describe what's going on in the water cycle. I wonder if there might be a class who might know and might be able to tell us those 3 key words.
3 key words in the water cycle. Well, Cambridge Elementary, Miss Hodgson's group, if you guys want to chime in, I know you have your mics off right now, but if you wanted to chime in and yell out what you think it might be, and of course, if you're on YouTube, you want to share in the chat, the more answers we get, the happier we are. This is our most interactive session of the entire Week of Wonder. Cambridge Elementary, what do we think? 3 words of the water cycle.
So we've got precipitation, evaporation. Anyone got our third one? Ara?
2 of 3. I think we got those right though. We got a dance going on.
You are. You're 2 for 3. I'm just waiting for that third word there.
Condensation.
Yay! You get 100% there, Cambridge Elementary. Well done. Condensation, evaporation, and precipitation. So I'm going to demonstrate that right here for you. So we have water coming from different sources, lakes, oceans, rivers, a puddle left out in the rain. That starts to evaporate. It goes up into the sky and forms a cloud. And when that cloud gets a little heavy, it starts to condense and then fall in the form of precipitation. Good. I did not. I made sure to aim really well. Thank you for the towel there, Stefano, just in case. So that process repeats again. It falls into sources. It evaporates. It condenses. And then it precipitates. And that process repeats again. It evaporates, it condenses, and it...
Wait, hey, Josh. The The water's gone.
I don't know. Anyway, let's explore that a little bit here. Why do you think sometimes it gets caught there? What's going on? Well, it might just simply be that it might have turned into snow, right? It might have been crystallized by water and it turns into snow. As a matter of fact, I was playing a little bit of a trick on you there, folks. If I can get it out. There we are. Now, this isn't snow. This is actually slush powder. But again, we are modeling things here. We are demonstrating weather through other things that kind of are very similar in some way. So we've got slush powder over here that can demonstrate snow. It can also demonstrate hail. Hail is simply when water just kind of comes up and down pretty rapidly and in between the clouds here. This is actually something that they use in the film and TV industry to create fake snow. So if ever you see fake snow in a movie, you will know that it's made from the same material that's in my hands.
Hey, Josh, just a hot tip there. That's the same chemical they use in diapers. So you just wash your hands after you're done there, hey?
Oh, yeah. Wash your hands, everybody. It's really important. That's absolutely right. That actual name of that powder is called sodium polyacrylate. So if ever you want to sound like a scientific genius in front of your friends and family, say sodium polyacrylate. It makes you sound intelligent, amazingly intelligent. In any case, let's explore the other kind of driving force of the water cycle. We've got clouds in our mists here. And clouds, I'm going to actually demonstrate a cloud here for you. So I've got some isopropanol, and I'm going to put it inside this wonderful 2-liter bottle. Wonderful, because it seems unassuming, but it's able to do some fun stuff for us. Now, I am using isopropanol because it evaporates a lot faster, and we need this to evaporate faster because that's kind of how a cloud is formed. Here we are. I'm going to plug that in here, and I'm going to call Stefano over here to help me out. He's got a pump over here, but we're also making sure that we are keeping ourselves 2 meters away, just out of safety's sake. And we are going to pump a certain number of pumps of air inside of this bottle, which will increase the pressure, but also increase the temperature.
All right, so Josh, I'm just pumping air into your little mini atmosphere there.
Yes.
And we're going to see a change. Is that's you're just putting air into a bottle? That's
not yet.
Okay.
Not yet.
What are we looking for right now?
Well, I will let you know when that happens.
All right. How many pumps do you want?
Let's put. I was going to think of 5, but 5 plus 1 is better. 6. Here we go.
All right, here we go. Count with us, guys.
Yes.
1, 2, 3, 4, 5, 6.
Our very big microphone picked up your counting. So good job here, everybody. I am going to pull out this particular stopper. Take a look.
Wait, hang on a second, Josh. Safety first.
Oh,
that's high pressure situation right there. Here's your goggles. I got mine. I'm not sure what's going to happen.
Here we go.
A cloud.
Ooh. Well, let me explain. That sudden when I pulled out that stopper, that sudden change of pressure resulted, and a sudden change of temperature resulted in this beautiful cloud. Now I'm going to put my hand right over here so that it doesn't disappear. And I'm actually looking for another class there. Is there a class who would like to name the cloud that we have made inside of this bottle? Jesse, do you happen to have a class perhaps who might be able to help us name this cloud before I leave?
What kind of name are we looking for? Like a real name or like Fred or John or
it can be the name kind of like a pet. It's totally fine.
Okay.
Any name is a good name.
Again, if you want to chime in on YouTube, by all means share. Bob is our name from iMan.
Oh, Bob is a good name.
Bob the Cloud. I like it. Any other thoughts on YouTube? Cambridge Elementary, I can bring you guys in a minute too, but if anyone has thoughts on YouTube, this is your moment. This is the only time you can name a cloud live in a broadcast. You can do it outside. I've got Billy. We got Billy and Bob so far.
I think we're going to call it Billy Bob the Cloud. That's
yeah,
a great
we're very
name.
country today. I like that.
Ooh, I'm surprised no one called it Cloudy McCloud Face. Anyways, let's make that cloud appear again. Here we go, Stefano. Billy Bob. It was Billy Bob. All right, here we go. Let's make the cloud appear, and Billy Bob appears. And let's make Billy Bob disappear, as a matter of fact. Here we go. And we're going to make him appear. And we're going to make him disappear. Go ahead.
That is a fickle cloud.
And we're going to make him appear. Fantastic. And now we're going to put him inside of our studio so he can live here forever. There he is. Billy Bob is all around. Thank you very much. Fantastic. All right. Now, going back to our exploration on water and its involvement in the weather, we were exploring clouds and how different types of precipitation come down from it. Snow, sleet, hail, and if you're from where we are, rain. Lots and lots of rain. Now that precipitation, as it falls down from the cloud all the way down to the ground, it sometimes picks up things that are in the atmosphere, different types of gases. For example, carbon dioxide, that particular one that we hear about a lot. Now, we can't see the carbon dioxide in the water, but if we have something called an indicator, that helps us out. I have a big flask here full of water and a small flask over here filled with some indicators that help us see the carbon dioxide, if there is any, in the water. Now, you'll notice that when I mix it with this water, it turns blue. Now, I have a pump right over here, and if I were to take this pump and pumped air from the room, we're making some bubbles over here. I wonder if you can see it. Thank you very much there, Stefano. It's always nice to have an assistant or a hand model there.
Thank you. I got a new career in hand modeling here.
Oh, yeah. Anything?
Nothing's changing, Josh.
You know what? I think I'm going to change it up just a little bit here. I just realized that I'm going to put my mouth on this. I'm going to actually just slip it underneath my mask. Actually, before I do that, I'm actually going to talk to you because it's kind of hard to talk with something in your mouth. So I'm going to put this other end of the tube on inside the flask, and I'm going to blow into it. Now let's think about what we blow out when we exhale. Type it out here. And as you type in that answer, I'm going to blow in that gas that we breathe out. And I want you to take a look and see. If you see anything happening to the flask, I want you to wiggle your fingers, go a little crazy.
I see bubbles. That's the same.
Oh, it's changing. Looks like it's changing to me. Nice hand modeling, by the way.
Thank you. Hey, Josh, you've just changed the color.
Oh, wow. Yeah, I'm looking at that, and I was like, I have the power.
You turned a little purple yourself with all that breathing.
Yeah. My lungs aren't perfect.
You're doing great. You're doing great.
Did you see anything there, everybody? I think I should probably bring it back there. I think from what I heard, you definitely saw things. So I put in a little bit of carbon dioxide inside of this flask from my air. Now, it's just a small amount of carbon dioxide that was put inside of this water, and it caused it to change color to yellow, telling us that the water has become a little bit acidic. Now, if there's a larger amount of carbon dioxide in the water, and if that water happened to fall down from the sky in the form of rain, well, that would be in a case of extreme weather that we would definitely not want to have happen. Something we call, quite aptly, acid rain. So that's when water or precipitation that has a high amount of carbon dioxide, or that picks up a large amount of carbon dioxide, falls down from the sky onto the ground, and it is pretty detrimental to plants and animals, including us humans. Oh, speaking of extreme weather events, was there anything? I think we had somebody mention something there. I think
check back with the classes in the chat, see if there's any other extreme versions of any of the stuff they've seen so far.
Yeah, let's get into some of the classes there. Was there anybody who wanted to have any? Was there anything in the chat, or maybe any classes who want to interact with us directly and tell us a little bit about the weather patterns that they'd like to see?
I know our other big one that we had a lot of was thunder and lightning. Like, that was by far the biggest other thing that we had. If Cambridge Elementary, if you guys want to jump in with anything that we haven't seen so far, you can unmute your mic and let us know. But thunder and lightning, hail, thunderstorms, we've got tornado, we got hurricanes, we got all sorts of fun stuff going on in the chat. So
Josh, while we're just waiting to set up, maybe explaining that, like, that sun warms up that the atmosphere, and the wind gets created, and that's where some of these other extreme weathers they're talking about.
Yeah, exactly. So when the sun heats up, and when there's uneven heating of the Earth, we have what we call wind, and that wind sometimes spins around in circles and creates those extreme weather patterns like hurricanes, like typhoons, like tropical cyclones. As a matter of fact, tropical cyclones, hurricanes, and the typhoons are pretty much all the same thing. It's just depending on what part of the world you're in and the naming of things like that. Someone also mentioned a little bit of lightning there as well. I'm thinking, do we have something?
We have a cloud.
We have a cloud. We do. We do have a cloud. I don't know that we can demonstrate lightning in here.
Yeah, no, I don't think so.
Yeah, it would be a little bit dangerous, and I would probably have to stay like 60 feet away from that. But I think, Brian, do we have a video by any chance? Oh, yeah. Is anybody celebrating a birthday today? Is there anybody celebrating a birthday in the month of September or even this week? As a matter of fact, I was thinking, because some of the students in your classes have birthdays in parts of June where you don't have class, in July when you obviously don't have class, and in August when you don't have class, and maybe that bit of December where you don't have class, or maybe that bit of March where you don't have class. Is there anybody celebrating a birthday in that particular part of the year?
I bet there is.
Big chunk of the calendar year.
Hey, in Miss Patterson's class, Chloe celebrated a birthday this week, which is pretty exciting. So thank you for letting us know in the chat. That's awesome, guys.
Awesome. Well, you know what? This special video is for you. Now, it's going to have some music here. And if you know the lyrics to the music, sing along. And then there's a part there where you can add the person's name there. Make sure you add that person's name as you sing along. All right.
And if you don't have a name, just say Chloe.
Yeah, exactly. Well, what an explosive end to that video there. Were any of you expecting that hydrogen balloon to suddenly explode? I'm pretty sure about 90% of you didn't. So I hope you enjoyed that. Happy birthday to you all, especially those of you who are celebrating the birthdays in those aforementioned dates. You know, it's someone's birthday any day of the year. So there's always a reason to celebrate. Now, that particular demonstration that we had over here was through something we call a Tesla coil. Perhaps you might have seen it if you've come to Science World, or if you go to a local science center in your area, if you're not from BC, or if you're not from the Lower Mainland, I should mention. And that particular thing is a demonstration of lightning. Again, it's a model. It's not a perfect thing, because lightning itself is an example of static electrical energy. It's an extreme example of static electrical energy, as a matter of fact. And that one isn't, but they kind of line up in a similar way there.
Plus, it's fun.
It is fun, yeah, and it's fun, and the fact that we were able to create music out of it with a little bit of finicking around with a Tesla coil made for a lovely, lovely video. So I hope you all had that. Well, you know what? I think it's time for us to turn the questions over to you. I think let's get some questions. Were there any questions from our classes in terms of what they saw, or maybe there might have been something that I didn't answer that they might want to have answered?
Yeah, so of course, our whole slew of classes on YouTube, if you guys want to start sharing now, Cambridge Elementary, I will come to you live to turn on your mic anytime. In fact, you can leave your mic on and we'll come repeatedly throughout the broadcast. I know when you were doing programs earlier, especially around clouds, is there a way that you can make it a dark cloud in that bottle? It was a very white cloud. It looked all fluffy. It was real Billy Bob as opposed to like a Lucifer or Pulsifer or anything like that. How can we make it a dark cloud?
That's a really good question. I wonder if we could put, are we able to put food coloring in there? Or, I don't
know. I've never seen anything like it. It's pretty cool though.
Yeah. This is a question where kind of my answer is I don't know, but you know what? I probably should try out. And remember there, everybody, sometimes when you're asked the question, saying I don't know is totally fine. It gives you impetus to search the answer out on your own. And sometimes exploring the answers or having an adventure of your own and answering a scientific question that you may have results in some pretty amazing fun.
I like when we
Yeah.
can start with a stumper, so thank you for our classes for that.
Love it. I love being stumped.
Mr. Anderson's class is joining us in Stony Plain. They've been joining us for all the week of wonder, and they wanted to ask with the isopropanol, is that material cold in any way? What's the temperature or the room temperature?
Well, we've got some isopropanol right over here. It is at room temperature. The real reason why it works really well as opposed to water is that it evaporates a lot faster. So we want if we have a drastic change in temperature, we have a drastic change in pressure as well, which results in a better cloud. So that's why we use isopropanol. You could definitely use it with water, and I've done it with water before. But optically speaking, when you use isopropanol, it gets a better thing. Always be careful as well there, everybody, because isopropanol is flammable. So make sure you have a trained adult if you aren't able to do this safely. All right. Oop. There we are.
Just drop it off camera. That's okay. All right. All sorts of questions coming in the chat. And again, Cambridge, let me know if you guys have one in StreamYard, and I'll come to you guys live. It's more fun to yell it out. Let's see. Why are some days more windy for Miss Halliday's class than others?
Ooh, that's a really good question. Why are some days more windy? Let me think about that. Well, Stefano, yeah, do you have the answer to that?
You caught me red-handed with some stuff here. So yes, So the sun, as Josh aptly put it earlier, does heat up the planet all the time. And of course, you can imagine that it heats up the planet evenly. So it's coming from the sun all the time, but the planet is turning. And of course, it heats up different things around the planet different ways. So that evaporation is the oceans warming up. And of course, there's so many variables on our planet within our atmosphere. So because some of the air might warm up off of land or off of the water in different ways, it's all kind of happening randomly around the planet. And we can track the way that things affect each other, but definitely certain days create different weather, as we've been exploring with the different pieces of the puzzle here today. So windier days just means that there's a different amount of air pressure and air temperature that's either moving from one part of the planet to another. And of course, because there's the different temperatures around the globe to the poles to the equator, that's always going to be affecting. It's always in movement. It's always changing. It's like putting some food coloring in water. It's going to swirl around in different ways. And depending on if there's air or heat or any of those elements that can affect it, it's going to affect it. So we have different windy days because we have different air pressures moving around the planet at all times.
I love that answer. One of the most easy ways to see this in your personal life, whether you're on a coast in BC, whether you're near a big lake like I am here in Ontario, is go for something called a sea breeze. So the land tends to heat up a little bit faster than the water, so all the air rises and you get this big breeze that comes in off the water. It usually feels different when you're near a water body, and so that's a really easy, close to home example that a lot of us can experience. All right,
awesome.
Cambridge Elementary, you guys had your mic unmuted a minute ago. Come on back in and share a question with us.
Yes, we were wanting a little more detail about what happened at the end of that happy birthday video there.
Ooh, are you talking about that balloon that exploded?
Yes, we had a question about that balloon.
That is a very good question. You've got some really observant eyes and ears there. So the reason why that balloon exploded was because we put a special kind of gas in there. Now, notice the gas, or notice the balloon. Was it floating, or was it kind of sinking, or kind of being held up in the air by someone or something? Think about it.
Yeah, so Cambridge, you guys can leave your mic unmuted the whole time.
Leave the mic on so we can have a conversation.
Oh, yeah, come on back in, guys.
All right, did anyone notice? Because I didn't.
Yeah, I noticed it.
What'd you notice, Deshaun?
I noticed that there was a bit of gas in the balloon, and when there was too much gas, the balloon popped.
Yeah.
So it was definitely floating. Do you have any ideas to what gas might be in there?
Maybe.
Mahi?
Gas.
Carbon dioxide?
Carbon dioxide. That's a good guess. Carbon dioxide is actually heavier. It has a heavier gas. And obviously, like I mentioned before, as you saw with one of our demonstrations, carbon dioxide is something we breathe out. So if you breathe out or blow into a balloon, you're putting a little bit of carbon dioxide in there. And so you know that when you blow your air into a balloon, it starts to fall. So it definitely isn't carbon dioxide. Anyone want to
those
venture
are
another guess?
Regular balloons aren't flammable, right?
Mm-hmm.
Yeah.
And regular balloons are normally not are flammable.
Nice question, guys. All right, we got a few more on YouTube. Guys, you guys are coming through with all sorts of great questions. This is awesome. Let's see. Miss Sterling's class wants to know, how does a hurricane happen? We were talking about wind a little bit earlier. I guess this is the ultimate manifestation of that. What's going on in a hurricane?
Yeah, so basically, it's just an intensely rotating low-pressure wind system that forms over tropical oceans. So it's just basically wind spinning over the water. So when it's over the water, it's called a hurricane or a typhoon or a tropical cyclone. And if it's over land, does anybody know what it's called if it's over land? If we have fast-moving wind that's circling over land?
I think we've had a whole whack of classes want us to talk about this. Tornado has been one of our big interests in today's program, so maybe that.
Tornadoes. So they were hoping that we would share something involving tornadoes. Is that what
that is the size of things? Yeah.
So they were hoping we would have a demonstration in terms of tornadoes, I guess.
I think so. Yeah. Do you have anything like that, or?
Well, Josh, I got some equipment over here. We can spin some air around if you'd like to see some air spinning.
You want to spin air around?
Yeah, okay. I mean, it's just air, and I need a plug. Here we go, just right here.
There we are. Good.
And just gonna, since you guys mentioned that air is spinning, I'm just gonna. This is just a little spinning air device.
Awesome.
Just gonna spin some air, and there you go. So, and there we go. So, Josh, if you could just explain to me why, in fact, well, we did drop this, but I caught it. Why, in fact, we don't have a tornado by just spinning some air? Maybe that'll get us to where we need to get to really get a good demo for these folks.
So the reason why we weren't able to see this tornado in action, and believe me, I didn't see it. I don't have special supersonic eyes that can see this tornado, is because tornadoes are usually visible because they pick up things. They usually come with a whole bunch of debris. So if tornadoes roll over a patch of grass, they're usually green in color. If they're over sand or dirt, they're usually brownish in color. If they've picked up a bunch of cows, they're usually black and white in color. I'm joking.
Or are you?
Thank you for appreciating my lame humor there, everybody. But in any case, in order for us to see a tornado, we need to have something be picked up. We need to have something there. Air itself is colorless. We need to pick up something. So do we have something?
Well, Josh, one of the demos we had earlier was really neat. It was very visible off the top of the show, was that fire that you had, and fire is very visible. And I might as well just mention that, unfortunately, one of the weather patterns that is happening more and more often, especially in our neck of the woods here in British Columbia, is fire tornadoes. The heat and the hot and cold air that is kind of thrust together inside of a forest fire sometimes creates what we call a fire tornado. We can't do that in the studio, though. I'm not equipped for that, nor it's safe.
I'm gonna call a no on that there. And also, I should draw your attention. I don't know if anybody saw up there that there is a fire sprinkler directly above Stefano's head. No, you can't see it on camera, but definitely. And if that fire sprinkler turned on, all of the fire sprinklers in our studio would turn on, and we'd probably be disconnected from everything. Brian is raising his hand, and I think do you have something? All right. Oh, he does.
Brian to the rescue.
Thank you so much, Brian. He's got a video over here involving the same equipment that we have, but in a better spot. So you can see that he's put this is actually Brian doing it himself. I wonder why.
He's always
Brian to the rescue. Yeah, so he has some isopropyl, and he's lit that up, and you can see that happening there. So obviously our tornado isn't happening because the spinning air isn't really being collected in one particular place. It's being collected all over the place. There isn't one central location it's being collected. So you can see that chicken wire that he's putting around, that circular chicken wire, and he's spinning it around. And as he spins, we have that beautiful fire tornado. Yeah. Thanks, Brian.
Nice job, Brian.
Take a look. Take a look at this.
What's he doing?
We've got reverse fire tornado.
Nicely done, Brian.
There's nothing better than a reversed fire tornado. You thought a fire tornado was great. A reverse fire tornado is even better. All right. Well, obviously, that was our fire tornado there, and now he's got to put it out. But he'll put it out in due course.
I think Billy Bob the Cloud was really excited at the prospect of being part of the fire tornado locally, but I'm glad we had an awesome video. Kids, when you came to class today, you thought it was going to be a normal class, and by the end, you were getting reverse fire tornadoes, which is pretty metal. It's like the most epic thing in the whole week of wonder. We're going to take 2 more questions before we wrap up. That was truly awesome. Cambridge Elementary, if you want to come back in for one more, unmute that mic, come on and join us live, and we'll take one more from YouTube.
It's tornado related, surprise. We are wondering, like, what makes some tornadoes like mega tornadoes, or was that like really big, and how they pick up people and cows and things.
I will actually defer this to Stefano, who will be able to better explain this.
Well, what a great question. I think that the synthesis of this is that all the parts of the weather cycle, those elements that Josh started off at the beginning of the class, play a role in how weather grows and shrinks and heats and cools. And so when you have a tornado, it is a hot and cold air, high pressure and low pressure air that are meeting. And of course, as we discussed earlier from that prior question about it changing on different days, when, like we like to say, a perfect storm happens. So when high pressure and low pressure airs meet, then they continue to get stuck in that pattern. It sometimes gets fed by more air that's in and around it, because air pushes, and it pushes its way into that space that is made by that low pressure air moving into the tornado. So sort of weather begets weather occasionally, and of course the sun heating things up and the land sometimes, or the water cooling things down, and all the elements that are at play in the atmosphere will control how big or small a tornado can be, which is why when weather people look at weather from a broad sense, they're looking at what's happening just outside of that weather pattern and what might feed it more, higher low pressure air or warm or cold air, and how it might diminish or augment that piece of weather. How it picks things up is, of course, the force of that strong, fast-moving air, and it can pick things up like dust. Hopefully not cows. We'd like to joke around about that, but no cows were harmed in the making of this science presentation. And so really just all those elements going together. It's just a math equation, and we like to study it, which is super important to observe the weather. All of us, a lot of schools have stations where they observe the weather, and you can look up cool resources for doing stuff like measuring weather, and that hopefully will help you understand it better and you know what's coming. We love to know what's coming in the weather, don't we?
Mm-hmm.
Fantastic, guys. This has been so much fun for me personally. I've had such a great time. I know our classes have too. What I want to do really quick before we do our sort of wrap-up message together is just highlight 2 of the programs we've got coming up or have in our past. As I mentioned, if you go to exploringbytheseat.com, you can see all our upcoming programs. Next week, we are being joined by George Crunas, Canada's chief epic weather explorer man in the world. He's been all over the planet to all sorts of amazing places. So you can see the world's weirdest weather with George Crunas. The other name I want you to check out on our YouTube channel is Nick Underwood. We talked about hurricanes earlier, and the way that we know how hurricanes are going to go up the coast, where they're going to hit, is that we fly planes into them. Amazing scientists take planes, normal planes, fly them straight into the hurricane, get bounced around like crazy. Nick Underwood is one of those scientists. So those 2 gentlemen, you can see all sorts of videos on our YouTube channel. Keep the learning going and hopefully excite you guys even more. Guys, this has been so much fun. I want to highlight again scienceworld.ca if you want to learn more about the amazing work that they do. They've got a picture up in a minute. They'll highlight some more great resources, but an amazing website, an amazing place. Hopefully you all get the chance to go in person soon. And without further ado, I'm going to bring them back in for one final message to leave us off with today. So Science World team, come on back in and tell us more stuff about what you're doing.
Yeah, one more thing we wanted to mention is this the Science World class bursary, which allows schools to be able to come on here with some financial assistance. So any schools that all across and online as well, I should mention. Yeah, you can also have a virtual field trip. So for teachers in the Lower Mainland and also all across BC as well, who are interested in having Science World visit them or visiting Science World, please visit scienceworld.ca/class bursary for more information. We'd love to have connections with you, whether in person or digitally.
Fantastic. Guys, this has been so much fun. Cambridge Elementary, if you want to join us with me in saying a big thank you and farewell, if you're at home, join me too. I know we can't hear you, but if you yell really loud, we might just pick it up. Thank you, guys. We really appreciate you joining us for this Week of Wonder, our first epic weather presentation. Really appreciate it, and hopefully everyone gets a chance to check out that awesome site to keep the excitement going.